Good afternoon all. One more portion of open course is pending. That's probability distributions. You have to learn about three distributions: the normal distribution, the binomial distribution, and the Poisson distribution. The first one is the binomial distribution. Binomial means we have two P and Q, success and failure. P is probability of success and Q is probability of failure, and we have binomial. There are two variables only. That's the binomial, the term binomial concepts. So we have performed a series of independent trials such that for each trial P is the probability of success and Q is that of a failure. Then the probability of R success in a series of n trials is given by NCR P raised to R Q raised to n minus R, where R takes any value from 0 to n. That's the probability binomial distribution formula. The probability of R successes in a series of n trials, NCR P raised to R Q raised to n minus R. So its mean is equal to NP. N is the number of trials, and the standard deviation is equal to square root of NPQ. So you have one problem. The probability that a pen manufactured by a company will be defective is 1 by 10. If 12 such pens are manufactured, find the probability that first one, exactly 2 will be defective, at least 2 will be defective, none will be defective. So for the answer, probability of a defective pen P is equal to 1 by 10, which is equal to 0.1, and therefore the probability of a non-defective pen, we take this as Q, is 9 by 10, which is 1 minus 1 by 10, which is equal to 0.9. So this is success. P is success. This is 0.1. Q is probability of failure, which is 0.9. Here given that there are n trials are there, so 12 is the n. Now we have the first probability of exactly 2 will be defective. So given that R is equal to 2. So this is our formula, NCR P raised to R Q raised to n minus R. So 12C2, 0.1 square, 0.9 raised to 12 minus 2. So the answer is 0.2301. Now in the second case, probability of at least 2 will be defective, which is equal to 1 minus probability of none or 1 will be defective, which is equal to 1 minus 12C0, 0.1 raised to 0, 0.9 raised to 12 minus 0. This is none will be defective, and this is 1 will be defective. 12C1, 0.1 raised to 1, 0.9 raised to 12 minus 1. So the answer is 0.3412. Now third case is probability of none will be defective, so which is equal to 12C0, 0.1 raised to 0, 0.9 raised to 12 minus 0, which is equal to 0.2833. Now the next distribution is Poisson distribution. Poisson distribution. When n is very large and p is very small, binomial distribution can be approximated to Poisson distribution. So here that probability of R is equal to m raised to R by R factorial e raised to minus m. In some text the notation is lambda instead of m. Here we used m. So this m is equal to the mean for binomial. This is NP. So we have one problem. If the probability of a bad reaction from a certain injection is 0.001, determine the chance that out of 2000 individuals, more than 2 will get a bad reaction. So we have n is equal to 2000. So n is very, very large and p is equal to 0.001. So it's very small. So mean is equal to NP, which we could take. This is equal to 2000 into 0.001, which is equal to 2. This is m, our m. So probability of more than 2 will get reaction is equal to 1 minus probability of none will get reaction plus probability of 1 will get reaction plus probability of 2 will get reaction. So which is equal to 1 minus this none in m equal to R equal to 0. M is equal to 2. 2 raised to 0, 0 factorial by 0 factorial e raised to minus 2 plus 2 raised to 1 by 1 factorial e raised to minus 2. 2 raised to 2 by 2 factorial e raised to minus 2, which is equal to 1 minus e raised to minus 2 can be taken outside. 2 raised to 0 by 0 factorial is 1. 2 raised to 1 by 1 factorial is 2. 2 square, 4 by 2 factorial is equal to 2. 1 plus 2 plus 2, which is equal to 5. So which is equal to 1 minus 5 e raised to minus 2, which is equal to 0.32. Now we have the normal distribution. When n is very large and p or q is not small, binomial distributions can be approximated to normal distribution. The normal curve is of the form y is equal to 1 by sigma root 2 pi e raised to minus of x minus mu whole square by 2 sigma square, where mu is the mean and sigma is the standard deviation of the curve. For the normal distribution, mean is equal to mu and variance is equal to sigma is equal to square root of npq to compare with the binomial distribution. So we can transform the normal distribution to standard normal distribution, which is the simplest form of normal distribution for when mu is equal to mean is equal to 0 and variance is equal to 1. Now we have one problem which convert the binomial distribution to normal distribution. And the first problem is, in a referendum 60% of voters voted in favor. A random sample of 200 voters are selected. What is the probability that in the symbol more than 130 voted in favor and 120 voted in favor? So here given that 60% voters are voted in favor. So P is equal to 60 by 100, which is equal to 0.6. So Q is equal to 1 minus P, which is equal to 0.4. And given that 200 voters are selected, so N is equal to 200. So N is large, neither P or Q not small. So we can approximate the given distribution to normal distribution. So mean is equal to, in the normal distribution, mean is equal to mu, which is equal to NP, which is equal to 200 into 0.6, which is equal to 120, and variance is equal to sigma is equal to square root of npq, which is equal to 200 into p is 0.6, q is equal to 0.4. So the answer is 48. 200 into 0.6, 120, 120 into 0.4, it's 48. So more than in the first problem is probability of 130 voters are voted in favor. So which is probability of x greater than 130. We can convert the given distribution to standard normal, so that means probability of x greater than 130.5. So which is equal to probability of z greater than, when we convert to standard or normal distribution, we have given the substitution x minus mu by sigma. So mu is equal to 120 here. 130.5 minus 120 by 48, which is equal to, that is probability of z greater than 1.516. So this we can find from the standard normal table. So the answer is 0.0648. Now probability of 120 voted in favor. So which is equal to probability of x equal to 120, which is equal to, we can take in a interval 119.5 to 120.5, which is equal to, now we can convert into standard normal distribution by giving the substitution x minus mu by sigma, which is equal to 119.5 minus 120 by 48 less than z less than 120.5. So here it is 20. 120.5 minus 120 by 48. So which is equal to minus 0.072 less than z less than 0.072. Again from the standard normal table we get the answer is 0.0575.